In this video, we're going to talk about special right triangles, and there's two different types. There is a 45-45-90 triangle, and there is a 30-60-90 triangle, and that refers to the angles that are inside each of the triangles. So, for a 45-45-90 triangle, if you realize that there is two angles that are the same, then this means that the two sides across from them are also going to be the same. So this is really going to be an isosceles triangle. So anytime it mentions an isosceles triangle, that really we have a right isosceles triangle, that we have this 45, 45, 90 degrees inside. So the way that the sides are paired up is we have this ratio right here, and this is one big thing you want to remember. So if you're given one of the side lengths, you want to, that's what this x is. So the x and the x refer to the two legs in the triangle. The last number is the hypotenuse. So you can see that in the picture. So if you're given one of the side lengths, this is the big thing you want to remember, is that you want to set it equal to the corresponding part in the ratio and then solve for that x in this ratio. Once you solve for the x in the ratio, then you can plug it back in and that'll give you all three of the sides. So in this first question, if both of our leg lengths are 6, then we want to find the length of the hypotenuse. So some of you might be thinking, well, couldn't you just do Pythagorean theorem? And yes, you could for a 45-45-90 triangle because we know that the two legs are the same. But this is going to help us for the 30-60-90 triangle, and this is a little bit faster actually to find it. So if you notice, I'm going to do a different color. So we have x, x, and x square root 2 are the ratio numbers we have up here. So if you have one of the numbers of the sides, you set it equal to that ratio. So that means all of our blue x's are 6. So that means in this ratio, I know I will have 6, 6, and then 6 square root 2. So if I'm looking for the hypotenuse, that is this last side, so my hypotenuse is 6 square root 2. So I'd like you to try this next one on your own. So you want to put your leg lengths of 3 square root 2 in there, and then you want to find the length of the hypotenuse. I strongly suggest that you use a different color for the ratio number, so that's my blue on there, and then my lengths that I gave you, the 3 square root 2, are the original numbers. So remember, if you have a side that's given to you, you set it equal to that ratio part of it, and then solve for the blue x, so the ratio x, and then you can plug it back in for all the other blue x's. So go ahead, push pause, and work out your answer, and when you're ready to check your answer, push play. Alright, so in your problem, we have 3 square root 2 equals x. Since we already have the blue x is 3 square root 2, we can go ahead and put that in for each of our numbers in our ratio. The part you might be a little confused about is how do we multiply these together. So if they're both inside the square root, we can multiply them together. So the 3 on the outside stays the same, but inside will become a 4. But then the square root of 4 is really a 2, so this is really 3 times 2, so our hypotenuse is going to be a 6. So for this next question, I give you the hypotenuse length, and you have to find the length of the legs. So again, we want to put the ratio numbers in our picture. Wherever we have a value, we want to set it equal to that ratio number. So there's my equation I need to solve. To solve for x, I need to get rid of the square root of 2 on the left, so I divide by the square root of 2, just like you normally would with some other number. And luckily, we have 2 square root of 2's on both sides, so we end up with our blue x is a 2. So then in our ratio, each of these blue x's is a 2. So then we can fill in what each of the different lengths are, and we're looking for the length of both of the sides, so both of the legs, that would be these two right here. So it would be a 2 for both of them, since they're going to be the same. So this next one I would like you to try yourself. Again, when you're ready to check your answer, go ahead and push play. Alright, so once you have your ratio numbers in there, you should have said equal to the x square root 2. The same thing happens on this one when you want to divide by the square root of 2. The square root of 2's cancel for both of them, so we end up with x equals 5 in your ratio. So that means all of these x's and my blue x's are going to be a 5. So we have 5, 5, and then 5 square root 2. And again, we want the legs, so that would be the 5, since we already had the hypotenuse to begin with. So go ahead and try the next one. So if you find the length of the diagonal in a square, if the side lengths are 6. So go ahead and draw a picture. When you're ready to check your answer, go ahead and push play. So this is what your picture should look like. Because it's a square and we connect our diagonals together right here, that means that this angle right here is cut in half. So they're both 45 degrees. So once you have the ratio numbers in there, remember you want to set the side that you have a value for equal to what the ratio is. That would be x equals 6. Since the side itself will also be 6, then that means in our ratio each of our black x's are going to be a 6. Since we're looking for the diagonal, that would be the hypotenuse, so that would be 6 square root 2 for your final answer. For the 30, 60, 90 triangle, it is similar to the 45, 45, 90 in that whatever length you are given, you're going to set it to the ratio of that side. So one thing I want you to notice is that the hypotenuse is always going to be double or 2 times the shortest side. So remember, you look at your angles to determine which is the shortest side and which is the longest side. So the shortest leg is going to be this x. The hypotenuse, since it's not a leg, the hypotenuse is going to be 2 times whatever that shortest side is. And then this long leg, so it's called the longer leg out of the 2 legs, the longer leg will be, we're going to take whatever this number is for the short side and multiply it by the square root of 3. So in our picture down below, right here, so I give you the triangle, the hypotenuse is going to be 12, and we need to find what the other legs are going to be. So remember, we want to label the sides of our triangle with the ratio. And I'm going to use blue again for this ratio. So the side that is, the value that is given to us, we're going to set it equal to that ratio number. When I solve this for x, I can divide both of them by 2, so my blue x is going to equal 6. So in my ratio, I know that since my x is the 6, I can replace the 6 with each of the x's. So that means that our hypotenuse is 2 times 6, so it's really a 12 for the hypotenuse, which is what we started with. So if you want to find the lengths of the other sides in the triangle, if you notice right here, now I have those 2 lengths. This is the way that I would write my answer, so I'd say that the shorter leg is the 6, and remember that comes from our ratio right there, and the longer leg is 6 square root 3, and that comes from the middle part of our ratio. Now I would like you to try, so if the longest leg is 5 square root 3 inches, I want you to find the lengths of the other sides of the triangle, so that would be the shortest leg and the hypotenuse. So go ahead, push pause. When you're ready to check your answer, go ahead, push play. So remember, when we have the length in there of 5 square root 3 inches, we're going to set it equal to that part of the ratio. To solve this for the x, we need to divide both sides by the square root of 3, so that eliminates. And luckily on the left-hand side right here, those also eliminate, so our blue x is going to equal a 5. When we put that into the ratio then, we end up with a 5 square root 3, and then a 2 times 5, which gives us a 10 for that side. So the 2 sides that we need, that we didn't already have, is the shortest leg and our hypotenuse. So again, I would like you to try with the next one. So you have an equilateral triangle. It has a side length of 10 meters, and I want you to find the height of the triangle. So remember, equilateral triangles means that all angles are the same, so that means that all 3 angles have to be 60 degrees to start with. When you're ready to check your answer, go ahead, push play again. When you first draw your triangle, when you draw it straight down, it creates this angle up here to only be 30 degrees each instead of the 60 that it started with. So that's the tricky part with this one. So then it gives you the side lengths as 10 meters each. From that, we know then that this bottom side has to be 5 meters because the length of that side is being cut in half with our altitude, or the height of the triangle. And then all you need to do is find the height of the triangle. So you could use Pythagorean theorem using your 10 and your 5 if you wanted to, or knowing that this is the 30, 60, 90 triangle, we could use the 30, 60, 90 ratio. So let's put that into our picture now. So we have 2 different pieces we could use. We could use the fact that we have the hypotenuse, so that means that our blue x will end up being a 5, or you could just use that from over here. So in our ratio, then we end up with a 5 square root 3, and then a 2 times the 5, which is our 10 that we started with for the hypotenuse. So the longest side that we're looking for, so the height of the triangle, is this 5 square root 3. These last 3 I would like you to try on your own. This is just more practice of the ones we've talked about. So go ahead, push pause, work out each question, and then when you're ready to check your answers, then go ahead, push play. So with this first one, when you put your ratio numbers in there for the 30, 60, 90 triangle, this is what I have, and I'm going to use red this time instead. So I have a value that is given, so my red x is going to equal the square root of 3. So I'm going to go ahead and put that into my ratio. The one piece that I can simplify is this right here, and we saw that with the Pythagorean theorem before, and that we get the square root of 9, which then just comes out as a regular 3 for that side of the triangle. So the piece that we are looking for is the longest side, and that would be the 3. For the next problem, we can see that it is an equilateral triangle, since we know that the bottom side is also 4 when I put those back together. So we know that the angles right here is going to be 60, and the angle up here at the top of the smaller triangle is my 30 degrees. I put my ratio numbers in there in red again, and the piece that I can set equal then are two different things. I could use this 2, so my red x is 2, or I could use the fact that 4 equals 2x, which again then x equals 2 in my ratio. So when I put the 2 into my ratio, I end up with 2 square root 3, and then my 4 for the hypotenuse again. So the only piece that I care about is the longer of the legs, and that would be this 2 square root 3 for my h. For the last one, it gives us a square, and that the area is 25 inches squared. So that means that each side length needs to be 5. And I know this because my side times my side needs to be the area, and the only way that happens with a square is if they're both the same, so that's 5 and 5. So next we could do Pythagorean theorem since we know it's a right triangle, or this is because it's 90 degrees to begin with, so these two angles right here in the corners are both 45 degrees. So you have to think of the other ratio that we had before, and that was x, and then our x square root 2 is the ratio we are using since it's a 45, 45, 90 triangle. So next, we have the ratio numbers we need to put into our picture. And I have the value for the x already, so x is 5. So my x's are all equal to 5, so we'll have 5, 5, and then 5 square root 2, and we're looking for the diagonal. So that would be this last measurement here at the end for my hypotenuse. So there is my diagonal of the square.